Need to make some adjustments here. We're over here at GoToMath.com working some application problems involving linear equations that we had gone over in a previous section. Okay, this problem here, we got 4.2. Find the dimensions of a rectangle with a perimeter of 32 meters if its length is 2 meters less than twice the width. So basically, this is a similar problem to 4.1. So you should pause the video and quiz yourself and see if you can work this one out. And then we'll compare notes. All right. Okay, so let's get busy here. Find the dimensions of a rectangle. So let's go ahead and attempt to draw up a rectangle here. We're going to attempt to do this. Well, that's not very good. Alright, there we go. Okay, we'll say this is the width and this is the length here. Alright. Okay, I found that it's actually important for me to freehand this stuff instead of coming up here and dragging down a box. And the reason for that is because if you were actually drawing this on a piece of paper, I want to be doing similar to how you're actually trying to work the problem out. And I found that just freehanding stuff on the screen, just like if you were writing it on your notebook paper, helps you out better, believe it or not. Yes, it does. Even though I don't write this stuff out because I just think that this is a whole lot easier to read than if I had to write it out by hand. Okay, especially I'm trying to write on a tablet, not on the screen of my computer, which would actually be nice. So Mr. Gates, if you could help me out there, I'd appreciate it. Okay, so find the dimensions of the rectangle with a perimeter of 32 meters. So let's go ahead and write that formula for finding the perimeter. So the perimeter is twice the width plus twice the length, right? Remember, that's the distance all the way around. Okay. And of course it's equal to 32, so let's go ahead and do that. 32 is equal to 2w plus 2l. Alright, now we need to get this equation all in terms of one variable. We need to get it either in terms of w or in terms of l, whichever one. So let's go ahead and keep reading. If its length is, so actually they're giving us a relationship here. Its length is, remember, is equal 2 meters less than. We'll say 2 meters less than. We'll put minus 2 here. 2 meters less than twice the width. So twice the width and 2 meters less than. So now we have a relationship between L and W. So where there's an L, we can go ahead and substitute. This will be our substitute here. So 32 is equal to 2w plus 2 times 2w minus 2. Alright, so now we have an equation with only one variable. Right. Now later on in algebra, we're going to show how to actually solve. If you have if you have two different variables, you'll need two different equations on how to do that. And let me tell you, that's some powerful stuff. Okay, because sometimes we can't find these kind of relationships. And if we can't find a relationship, then we'll be doing something different. Alright. Okay, so let's go ahead and solve for W here. We will distribute this 2 across. That's going to be 4w minus 4, and therefore we have 6w minus 4, and there's 32 over there. So we'll go ahead and take that 4 now over to the left, and that'll be adding 4. And that's going to be 36, right? We'll go ahead and continue this over here. So 36 is equal to 6w. And we can just look at this, right? 6 times 6 is 36. So w is 6. W is 6. And now to find L, let's squeeze that in right here. L is equal to 2 times 6 minus 2, so that's going to be 12 minus 2 is 10. 12 minus 2 is 10. So we now have the dimensions to our rectangle. We know that this is going to be a 6 by 10. I guess you could say a 6 by 10. Right? There you go. Okay. 6 by 10. That 10 needs to be worked on a little bit. Okay. So we're over here at gotomath.com. Get it figured out. And I'll see you in the next problem.